90% of developers are building AI agents that are basically goldfish with a high IQ. If your agent forgets who you are or what you did 5 minutes ago, the moment you start a new session, it isn't a teammate, it's just an expensive autocomplete. Everyone says you just need a vector database and you're good, but they're dead wrong. To build an agent that actually evolves, you need to architect a memory system that mimics the human brain. Today, we're tearing down the stateless model and looking at the anatomy of agentic memory. Let's dive in. Think about how you work. You have a scratch pad on your desk for immediate notes, a diary of what you did yesterday, and a library of facts in your head. AI agents need the exact same thing. We call this the 3-layer stack. At the top, you have working memory, the now. In the middle, there's episodic memory, the timeline. And at the bottom, there's semantic memory, the knowledge. Most people try to cram everything into the top layer, but that's like trying to run a multi-billion-dollar company using only post-it notes. It's messy, it's expensive, and eventually the notes fall off the wall. Let's start with that top layer, working memory. In the AI world, this lives in the KB cache. Think of this as the model's active RAM. Every word you type and every response the AI gives takes up space here. But here's the problem. As the conversation gets longer, the context bloat becomes unbearable. It gets slower, more expensive, and the AI starts to lose the thread. But what if you didn't have to store every single token? What if you could just store the vibe or the intent of the document instead? That's where things are changing fast. This is where MIT's attention matching comes in. It's a breakthrough that allows for 50x compaction of that memory cache. Instead of saving every raw word, the system preserves the attention behavior. It's like reading a 500-page book and only keeping the highlighted sentences that actually matter for the plot. This results in a staggering 98% reduction in context costs while keeping that needle in a haystack retrieval performance. You get the same accuracy, but your GPU isn't screaming for mercy. This is the foundation of a persistent agent that doesn't go broke just by talking to you. Now move one level down to episodic memory. This is the chronological log of what happened. It's not just about facts, it's about the sequence. If you ask your agent, what did we decide in last Tuesday's meeting, a standard search might fail. But episodic memory uses append-only logs and timestamps to perform temporal reasoning. It's the difference between knowing that Paris is the capital of France and remembering that you told me you hated Paris 10 minutes ago. Without this stream, your agent has no sense of time. It lives in a perpetual now, which makes it useless for long-term projects. Then we have semantic memory, the knowledge vault. This is where we store distilled facts and user preferences. Most people jump straight to vector databases here, which find things based on similarity. But here's the thing, similarity isn't always relevance. That's why the best architectures now use a hybrid of vector DBs and knowledge graphs. While vectors find things that sound similar, knowledge graphs map the actual relationships between concepts. For complex queries, this graph-based approach can offer 91% lower latency. It's the difference between searching a pile of loose papers and using a perfectly organized filing cabinet. But the real holy grail is moving memory inside the model itself. Google's Titans architecture is a glimpse into this future. It uses something called a surprise metric. This is genius. Instead of storing everything, the model only updates its internal weights if the information is unexpected. If you tell the AI the sky is blue, the surprise is low. It ignores it. But if you say the sky is neon green today, the surprise is high, and the model updates its neural long-term memory on the fly. It's learning in real time, just like you do when something shocking happens. We also need to talk about procedural memory. This isn't about what happened, but how to do things. Advanced agents use frameworks like MEMP to store trajectories, sequences of successful actions.
Imagine your agent tries to deploy code and fails because it forgot to check the database migrations. In a basic setup, it just records the failure. But with procedural memory, the agent updates its internal playbook. Next time, it automatically adds a check migrations step. It's a self-evolving loop where the agent literally gets better with practice without you ever having to touch the prompt. So, how do we tie this all together? We use the write-through cache pattern. When an agent learns something new, it's written to the short-term context and then moved to the long-term vault by a consolidation worker. This increases response accuracy by 26% in production. If you want to build this, look into the Model Context Protocol or MCP. It lets you build a dedicated memory server that any AI can plug into. Stop building goldfish, start building agents that remember. Try implementing a simple reflection loop in your next project and see the difference. If you found this deep dive useful, subscribe for more. I'll see you in the next one.